Hello, my amazing students. This is Mrs. A, and today we're doing 2.5, which is all about our transformations. When we are stretching and compressing, reflecting, and shifting our functions. Okay, so I'm going to do about every 10th one in the back of the book in the problem set, just to get you familiar. If you're watching this, you're probably getting ready for a test, which could be Tuesday or Wednesday of this week. So I want to make sure I get this out for you. All right, so here we go. This is number 10 in the back of the book, and it says f of x is 2x plus 1. Now what we're supposed to do is take one of our parent functions, and they said that the parent functions were found on 129 of the book, and so I've listed the parent function that we're going to be playing with here. And I have a shine on my board. Let me see if I can get rid of that shine on the board, if that will help it a little bit. Yeah, I don't know. Maybe just get rid of that altogether. Well, I shut the blinds as best I can do. All right, so we have this parent function that we're talking about. F of x is x, which is our parent line. And this is what the parent looks like. It is a 45-degree line straight through 0, 0. And it's called our identity function because everywhere on that line, x is equal to y. Okay, so the point 1, 1, 2, 2, 3, 3, those are all on that line. So to get from here to here, we're going to do a vertical stretch by a factor of 2. There's our stretch right there. And then we're going to shift it up 1. So if I were going to do the new function, it would not have a slope of 1. It would have a slope of 2. So it would be going up 2 over 1. So it's going to be sharper. Okay, but not only is it going to have a sharper slope, but it is also going to step up by 1. So we're going to have a different y-intercept, and then it's going to go up by a factor of 2 over 1. Okay, so up 2 over 1. So we have a sharper slope, and it's going through the y-axis at 1 instead of at 0, like the original function was. Okay, so then let's look at number 20. And number 20 said f of x is negative 1/2 square root of x minus 1. Now we're using the parent function of the square root function. And we're trying to talk about what kind of shifts and changes are happening to the original function here to get the new function here. Okay, so remember when we have something happening inside the function, it's going to move it left or right. In this case, it's going to move to the right because 1 would make this go to 0. So we're going to move everything to the right 1, and then it's going to have a vertical reflection across the x-axis and a compression by a factor of 1/2. So if we were going to graph this one, we're going to have to shift it over by 1. So we'll do our 1 there, and we're going to reflect it down. So it would be going like this. However, it's also shrinking, which means it's going to be skinnier to the x-axis there. So that's just an approximate of how that's going to change. Okay, so back with more problems. Okay, this one is number 30, and f of x is 2/3 of x cubed, take away 4, and our parent function is f of x is x cubed. Now the black graph here is your basic x cubed graph. Now, when you are doing these on a test, you're going to want to make sure that you put some points in there. This one, the x squared graph goes through 1, 1, and it goes through negative 1, 1. So if we were going to, because my graph is kind of small, this point right here would be 1, 1, and this point down here would be negative 1, 1. Okay, so it's important on graphs to have some points. When I compress it vertically by 2/3 and I translate it down 4, then the 0, 0 point in the original graph will move down here. Okay, so now in the graph of the new function, I would have I would plug in a 0, and then I would get a -4. So 0, -4 is a point, okay? And then if I went to the right one and I put in a 1, then 1 cubed is 1, and I would get 2/3 of 1, take away a 4. So I would get a -3 and 1/3 there for my second one. And then my point over here for if I plugged in a -1, then I'd get a -2/3 minus 4, or a -4 and 2/3. So that's just a couple of points that would be on the new function. And the new function would look about like that blue one that I have here. It's going to be just a tad wider than the original function because a compression flattens out the function a little bit, which makes it look a little wider, and it's going to slide down 1 step. So hopefully you can see that blue function is right there, and it's just a little bit wider than the other one. But then on a test, I would need to see some actual points for the new graph. All right. All right, this one is a good one because we're starting with a point, -12, 4, and they're saying if that is the original point on y is f of x, and then we have these transposed functions or transformed functions. This one has an inside multiplying by 4. Remember, if it happens inside, it actually winds up, that 4 times ends up dividing the x by 4. So the point here, -12, 4, is going to be on the new function, -3, 4. So that 4 divides the x, the original x that goes in. And then on this one, f of x minus 2, that's going to be a translation downward. And remember, if it's downward, it's happening to the y point, the y coordinate of the point. So -12, 4, down 2 steps on the y would be -12, 2. So those are very, to me, those are fun to do. Okay, so these are 2 more of those. We have the original point still 12, -12, 4. And then we have g of x is 4 f of x. So the 4 is outside of the function. And in this case, it's going to multiply by 4. And since that's happening outside, it's a vertical change. So it's going to multiply the y by 4. So you would end up with -12, 16. I wrote that wrong. -12, 16, which would be the original point multiplying the y value by 4. And then down here on number 39, we have f of -x. We know that since that's happening inside the function, it's going to flip it this way, which is left to right, and that's going to be a reflection across the y-axis, and that's going to change the x value of the point. So I'm going from here, -12, 4, which would be over there, all the way over here to +12, 4. So +12, 4 would have been the answer. All right, so now we continue with y is the square root of x. And if we were going to take that parent function and we were going to shift it left 6 and down 5, we would end up shifting it left 6 inside the function, which would make it x plus 6, because -6 makes that go to 0. And then down 5 would be outside the function. So this would be my new function, and that's on number 50. Okay, then 54 is this one. We have y is x squared, and we're going to translate this right 6 and up 2. The right 6 will happen inside the function, And again, 6 would make this go to 0. So I'm translating it from 0 to the 6 to the right. And then outside the function would be my translation up of a plus 2. And that's what number 54 should look like. Number 58 is a little different because it's one of our graphs that I told you to memorize the shape of. Let's graph the parent function again, just so that you remember this one. It's going to be like this and like this. Okay, now it says the new graph is going to be reflected across the x-axis. Well, across the x-axis would bring this one flipped down, and then it's going to bring this one flipped up. So it's going to totally change the look of that. And then it's going to be moved 1 unit up. So algebraically, this negative in front of the 1 over x is what's going to flip it. And so the new graph is going to be down here and right there. That's the reflection. And then it's going to be 1 unit up. So I have to slide this up 1 and slide this up 1 so that this one will actually cross over the x-axis, and this one will slide up 1 too. But the algebraic function is now negative 1 over x, and then outside the function plus 1. If I was to get a common denominator there, then the function would wind up looking like this, because I would take my negative 1 over x and I would write my 1 as an x over x. And then when I added my common denominator rational expressions together, I would get x minus 1 on the top and an x on the bottom. And so that would be the algebraically correct way to write the new function. And it would be this function here, but it would be up a little bit higher there. And then this one on this side would actually just cross over just a little bit. And that would be your new function. That's number 58. This last one that I'm going to do for you is a lot of fun, a little tedious, but a lot of fun. Okay, so this was the graph that we were given in the book. And the book's one looks a lot better than mine, but I've basically just graphed the very nondescript shape, and I have graphed some points on it. So this is what it looks like to start with, okay? And then problem number 67 says that we're supposed to take that graph, and of course I just took the high points and the low points and the points that were distinguished in there, and we're supposed to come up with a new graph. H of x is negative g of x plus 2, and then outside the function plus 1. So when you look at this negative on the front is going to reflect it down across the x-axis. That's going to be a change on the y coordinate. Okay, when I reflect across the x-axis, I'm changing my y from a positive to a negative or vice versa. Okay, then when I'm moving left 2 inside the function, this is going to be an x-coordinate change. Okay, and then when I move up 1, that's a y-coordinate change. All right, so what I did, since I was going to reflect down left 2, up 1, I went ahead and did them, each one of those points that I showed you. I started here with the original point. Okay, so in this first column here, all the way down, I shifted it left 2 from the very beginning, left 2, which was the what was inside the parenthesis. Okay, so here was my function again. Okay, this part right here tells me to shift it left 2. So I went ahead and did that first. You could have reflected it first. I went ahead and did that because it was inside the function first. So I shifted it left 2, here, 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 which changed the x coordinate. I took negative 7, 0, and I moved it left to negative 9, 0. Notice it did not change the y coordinate. The second instruction was reflecting it across the y-axis. And that one did change the y-coordinate. Okay, so it didn't change it here because the y-coordinate was 0. But on the second point, it was negative 5, 4 to start with. I moved it left 2 on the x-axis, x-coordinate. And then I flipped it, changing the 4 for a negative 4. That was my reflection across the x-axis. And then lastly, I stepped it up 1 with the translation upward, so that affected the y-axis, and I stepped up to negative 7, negative 3. So all of these points I have checked, so they're all correct in the book. But this one was, this column right here was where I took each one of these original points and I moved it back to a translation left of 2, which affects the x-axis. Then I took each one of the points that resulted here and I reflected it across the y-axis, which changes the y, the sign on the y term. And then lastly, this last column here, I moved it up 1, translated up 1, which happens outside the function and affects the y coordinate. Okay, so let's just take the last one here. 5, negative 2 was the original point. I moved it left 2 by putting a 3, which is 2 steps to the left. So left 2, 3, negative 2. And then I flipped it, which is a reflection across the x. The negative 2 becomes a positive 2 on the y. And then lastly, I moved it up 1. I translated it up 1, which affected the y. Those are your points. All right, so this is our last one on section 2.5, and then I'll get that one online for you so that you can use it to study for your test. This one is number 82, and I thought it was intriguing because what they give you is they give you the original function, and in the book they give you a graph, so I encourage you to go and look up the graph. When I looked up the graph, it had these basic 4 points noted on the graph, and then it showed me a new graph, and that was how the points changed on the new graph. And I'm supposed to come up with a new equation for the new function. Well, I noticed that between the old one and the new one, the y value was cut in half. The y value did not change because cutting 0 in half doesn't matter. But the y value here was cut in half, and right here there was no change because the y value is 0. So I said, okay, the y values are being cut in half, and the function does look more spread out vertically. And so I said that's a vertical compression of 1/2, and I wrote the new function out here. Remember, if it's happening to the y coordinate, it's happening outside the function, which means that the 1/2 is outside the function and not inside the function. And that is the end of 2.5. And this is Mrs. A, and may God bless your day.